Okay, let's run through a couple of slope field. I found some things for us to practice. So why don't we do a couple of slope field examples, multiple choice examples, and then we can move on to other topics. If you're trying to match a slope field with something that is at the function level, then you're simply just looking at the flow or the shape of the graph. And here, if we just start at a point and just kind of follow where that graph is headed, what does that look like to you? Does that look like a cosine x squared e to the negative x, e to the x, or natural log of x? E to the x looks more like this. Yeah, this is the natural log, right? So this is, you can also sketch this in your calculator and see that shape show up. Let's do another similar one here. Number 4, this is also matching at the function level. And if you just pick a point and then just kind of follow the flow of the graph, what does that look like to you? Cube, yeah, cubic function, right? Sine x, sine x is going to be like a wave. So is cosine. This x squared is a parabola. 1/4 x to the fourth is also a parabola, but x cubed is kind of has that shape, right? Now, if we're looking at this from the derivative standpoint, then we have to look at some behavior in terms of, okay, where do I see positive slopes? Where do I see negative slopes? Where do I see slope zeros? Where do I see slope undefined? So here, tough to see. I don't really see any slope zeros, right? We don't see any horizontal lines. We do see a couple of slope ones. These all look like slope ones here. Okay. It's hard to tell if there's any undefined slope. Okay. But that's a possibility. It's just sometimes things may be covered up by the x or the y axis. Another strategy is to look at the choices and see where are the choices indicating slope zeros. So for instance, if I look at part D here, where does this tell us slope 0 should occur? When x is what? 1. So basically when x is equal to 1, basically that's over here, right? It should be showing me slope zeros. Is that the case though? Do we see slope zeros here? No. So we know that this is the wrong choice, right? So I think that's a good way to eliminate wrong choices. You look at what the choice is telling you where the slope 0 should be. And if we don't see that on the graph, then you can just quickly eliminate it. Right? In this case, I mean, obviously we can also say slope 0 and y is 0, but this is a little bit easier to spot. So this one, okay, where is this telling us slope 0 should occur? When y is 1, right? Because 1 minus 1 is 0. So when y is 1, that's basically along this y equals 1 line. It should be showing me slope zeros, but it's not. So I know this can't be the right option. Here, x plus y, right? So maybe I think about easy order pairs like 1 plus 1, or 2 plus 2, or 3 plus 3. But if I see 1, 1, and 2, 2, and 3, 3, is my slope increasing? So this should be slope 1, this should be slope 2, this should be slope 3, or sorry, this should be 2, 4, and 8. But do I see that progression here? It doesn't quite fit, right? So this one seems to be out. Okay, so I'm down to x over y or y over x, and both of these kind of fills this condition, right? Because 1 over 1 or 2 over 2, it's all giving me, looks like all giving me slope 1s here. But what if I continue to look at the first quadrant and I pick up order pairs like 2-1 or 3-1 or 4-1? What should be happening then? If I do like 2-1, 3-1, 4-1 for this, my slope should be getting steeper, right? 2-1, 3-1, 4-1. And I kind of see that happening here, right? 2-1, 3-1, 4-1, 5-1. It's all becoming steeper. But this one would be different. This one should be 1/2, 1/3, 1/4, but these don't look like 1/3, 1/4 to me. These look more like, positive, like 3 or positive 4. Because 1/2, 1/3 should be like almost a straight line. It should be like barely positive slope. So I think our best option is going to be B. Yeah.
Are you assuming that the y value stays the same though when you're?
I'm sorry?
Are you assuming the y value stays the same?
Yes. Yeah. So I'm just looking at this line here. Right. These are order pairs like 1-1 or 2-1, 3-1, 4-1, 5-1. And that kind of meets the criteria that I'm expecting, right? Looks like I should be expecting a progressively steeper slope, and I do see that a little bit. Okay, let's look at number 3. Okay, what are some things, anything that you guys notice, or maybe you notice there are some wrong choices that we can just go ahead and eliminate?
The greatest steepness is like the parts to the left and leave the least amount of steepness.
Yeah, so give me an order pair, like what order pair are you thinking about?
Like 6-1, it's like super steep.
Right here?
Positive, or -6-1, it's super steep to the positive, and then positive 6-1 is like super steep to the negative.
Yeah, that's good. So I can do that, right? I can pick -6-1, and I insert in, and I should get a pretty large positive number, like a 5 or 6. And likewise, if I pick 6-1 here, or 6-1 here, I should be getting a negative slope, right? So that's one way that we can insert and eliminate some wrong choices. So what are some ones that we can eliminate from our options? D and E, right? Also, I see that when X is 1, I should be getting 0 slope. I don't see that at all here. And when Y is 1, I should be getting 0 slope, and I definitely don't see that here. So I like that strategy of just eliminating the wrong choices, and then you have less to worry about.
I didn't know those were wrong.
Because when Y is equal to 1, what should my slope be getting back in return? Right. If I plug 1 in for Y, what should I get? What's 1 minus 1? 0. 0 times anything is 0, right? So Y equals 1, that's going to be everything here. When Y is 1, I don't see 0 slopes here, so that doesn't fit.
Same with
Yeah, the vertical line is out. I think B should be out as well, because if I were to insert, EC is out. If I were to insert 1 and 6 and for Y and X, I'll get -1/6. And -1/6 doesn't look like that, right? -1/6, that looks like more of a -5 or -6. So we know this one is out.
X over Y and Y over X, are those supposed to like go straight to what X-axis or origin?
Yeah, we can look at the X and Y axis as well. So this one here, when y is 0, I should be getting undefined. But it looks like this is not undefined, right? This is showing me there should be a blank space here, but I don't see a blank space here. So this one is out. So I think y minus x could be the best fit, because if I were to test different order pairs here, also there's something helpful here, right? That we have all these slope zeros, and these slope zeros kind of match up with this, right? So like order pair 1, 2, which is 2 minus 1, or 3 minus 2, or 4 minus 3, they're all producing these slope zeros. Yeah.
I feel like if you did 2 minus 1, that's a 1. So how would
Okay, give me an order pair. Which order pair are you looking at?
it should be 0.
Two. Let me see. Oh, I'm sorry. 1, 2. Sorry. 1, 2 is a positive slope. I think. And that should make sense, because any second quadrant value I can think of, let's say -1, 6, I'm always going to be 6 minus a -1. It's always going to produce a positive value for me. So anything in that second quadrant is producing positive values. Okay, so but if we eliminate all the wrong choices, then we have an easier time kind of figuring out which one could be the best fit. Okay, let's go to page 3. There's nothing on page 2 that has multiple choice, so. Okay, we have a couple options here. Getting 0 slope. I know that when y is equal to 0, I should be getting slope undefined. I know that first and third quadrants should give me positive numbers, because 2 over 2 or -3 over -3. So quadrant 1 and quadrant 3 should be positive. Quadrant 2 and quadrant 4 should be negative, because if I imagine -2 over 4 or 3 over -1, right? So the quadrants are going to be very specific, right? Only one type of slope is going to exist in each quadrant. slopes here, right? Every quadrant should only have one type of slope. Here, there's a mixture of different slopes. Yeah, D. You know, we don't see positive slopes in the first and third quadrant, so this is the opposite.
Quadrants have the same slopes.
It looks like it, right? Based off of this expression, right? Because if you think about any order pair, anything in the first quadrant should give me a positive number. Anything in the third quadrant should give me a negative, positive number as well. Because the differential equation is simple enough where we can create those easy categories for us. Okay, so we're down to C and E here. Which one do you think this is? Okay, it is between those two. But there's one more thing. There's one more thing is what happens when X and Y are the same value? Like 1 over 1, 2 over 2, 3 over 3. It's all equal to 1. So I should see a bunch of 1 slopes all lined up. I don't quite see that here, right? 1, 1, 2, 2, 3, 3, 4, 4, -1, -1, -2, -2. But here, I see that relationship. I see a bunch of 1 slopes all lined up here. So I think E is going to be the best option.
How do you know those are one slopes? So we know they're like slope ones.
Yeah, because slope 1 kind of has a 45-degree look to it. Because you do up 1 over 1, it kind of has that that diagonal shape to it. But here we see that 1, 1, 2, 2, 3, 3, 4, 4. It doesn't look like it's a consistent slope, right? It looks like it's getting steeper, so it doesn't quite fit what we know to be true about that. Okay, page 4. Okay, so if I look at my slope field here, it looks like I can also identify certain slopes in each quadrant, right? So what do you notice about quadrant 1 and quadrant 4? Yeah, mostly positive, right? I mean, I think even these are positive because these are just very gradual slope, but looks like quadrant 1 and quadrant 4 mainly positive slopes. How about quadrant 2 and quadrant 3? I think this could be a big clue to start eliminating choices that are not going to fulfill these conditions. Which one can we eliminate for sure? Yeah. B, yeah. Right, because B tells us that everything should be positive, right? Everything is being squared, but I see a couple of negative slopes here, so B is definitely out. What else is out? A, yeah, because quadrant 4 should be positive, but if I insert any order pair into quadrant 4, I'm getting a negative, and that's not consistent with this, so this one's out. Yeah, D is also out. Okay, we're down to C and E. D is out because if I were to insert order pair, if I were to insert 3, -4 in the fourth quadrant, I should be getting a positive number, but this is giving me a negative number. So this doesn't fit. Like this fourth quadrant, I see positive slopes here. Okay, we're down to C and E.
Would be out the Y squared.
Well, let's double check a couple order pairs here. So 1, 1 should give us positive. 4, -1 should give us positive. -2, 2 should give us negative. And -3 should give us negative as well. So let's just test it, right? If I plug 1, 1 in, am I getting positive or negative? Positive. If I plug in 4, -1, am I getting positive or negative? Positive. If I plug in -2, 2 in the second quadrant, if I plug in -3, 3, getting negative. So I think this fulfills the conditions, right? Because first and fourth quadrant are positive, second and third quadrant are negative. I think E is the correct answer. Well, it is perfectly aligned, but you're not going to test every point. You're just going to eliminate the wrong choices enough so that you can pick the right one, because we don't want to be testing, 30 points to convince ourselves, right? Just enough so that we can, if we can find one thing that is wrong with our one thing that conflicts with our answer choice, we want to just eliminate it, right? So I like to look for the wrong answers. That way, I'm not having to convince myself over a ton of points to figure out if something is right or not.
Usually look at 1 point for each quadrant.
Yeah. Or I mean, once I'm down to 2 choices, then I'm looking in each. Then I'm looking more carefully, right? But it's nice to have a big general observation to eliminate the obvious wrong choices. And if you're down to 1 or 2 choices, then maybe we have to look more closely at order pairs. And again, we can't tell a slope 3 from a slope 6, but we can tell a slope positive versus slope negative. So we can use that to our advantage.
We're doing number 5. Is that really a question?
Number 5 is like solving differential equation. Yeah, why don't we do that? This is a cross multiplying, use substitution type problem. So yeah, I think this is a good one to do. Okay, let's try number 5. Okay, so once I cross multiply, I can get that dy and dx all lined up. Do we have full separation of variables at this stage? Yes. Yeah. So we can put a 1 in front of dy to make it easier to identify the integral rule. So what's the integral of 1 dy? You got the right idea, but what variable do we choose for this dy? Y, yeah. Okay. And then the right side, we got to go through a little bit of what? U substitution, with the u value being 2x. Yeah, so we go through u substitution. It'll produce eventually a 1/2 that's going to have to come out. And that 1/2 with the 3 will produce a 3/2. Right, because u is 2x, derivative is 2, cross multiply, dx is du over 2. What's the integral of cosine? sine. Yeah. So 3/2 sine u plus c, replace the u back in terms of x. And then once we have our equation, there's no need to clean up the left side. It's ready to go. The only thing left to do is to solve for c, plug pi over 2 in for x, 2 in for y. We get sine of pi. Sine of pi is 0. That's going to wipe this whole thing out. So c equals 2. And if c is equal to 2, I can put c back into my general equation. Yes.
How did you know the derivative rule for sine? Cause like antiderivative, it's not, like, why is it not, like natural, what's the natural? log?
Oh, right. So the natural log are the newer rules. So these four, right? Integral tangent, integral secant, integral cotangent, integral cosecant. I'm sorry. Everything but cosine and sine. Well, we know that trig integral rules are coming from the original derivatives, right? So if it doesn't show up on the right side, then we don't have an integral rule from the original 6, right? Because integral of sine is negative cosine, integral of cosine is sine. We have integral rules for everything on the right side. So if it doesn't show up on the right side of the derivative rule, then it's going to have to be one of the original. It's going to have to be one of the log rules, or ones involving logs, natural logs. Okay. Any questions with these here? Okay. Let's go. Well, I figured that maybe I'll have you guys try these other problems later, and I will send out a link this afternoon with the key so that you guys can check your answers. I think it's good for us to have some ones that we don't do so that we can practice on our own. But I'll send out a link to the key through Remind this afternoon so that you guys can check your answers. Okay, let's go to page 11. Did we do number 2 on page 11? This is from the your test review packet.
Oh, we didn't.
We didn't. Okay. All right. So let's do a full problem of we're not doing domain, but solving the differential equation of tangent line, linear approximation. Let's see if we can line all those up and make sure that we don't have any trouble with those. Okay, so we start off with cross multiplying. I have x dy equals dx. So the dy dx's are in place, that's good, but do we have full separation of variables yet? So what needs to move? X. So where's x gonna end up?
To the right.
In the what? Denominator, yeah. Now do we have full separation of variables?
Yes.
Yes, y is on the left, x is on the right. We can put a 1 in front of the dy to help us with our integral rule there. So 1 dy becomes y. 1 over x on the right side becomes natural log, absolute value of x. There's nothing left to do on the left side. There's no need to raise both sides with base e because y is already by itself, right? We only do that base e if the left side has natural log and we're still trying to clean up the left side. But the only thing left to do is to solve for c. So what can we use to solve for c? Yeah, order pair 1, 1. So 1 in for x, 1 in for y. So there's our specific equation solution for part A. Okay, next part, we're going to skip domain. Part C, find the equation of the tangent line with x equals e. So what information do we need to find tangent line? And slope and what else?
Oh, points.
Points, right? So do we have information about the point? But do we have the full order pair? How can I find the full order pair? But they're only giving us the x value. Plug, yep. So plug into which equation? Which original are you talking about?
One over X.
Well, this is dy dx. This won't give us order pair. Yeah, this one. Yeah. So at the function level, this will give us location. So if I plug e in for x, what's natural log of e? 1. 1 plus 1 is 2. So there's my order pair, right? How can I find the slope?
What about that?
Well, I think it's kind of hard to tell by the graph.
We use the 2 points we have.
Sorry?
We use the 2 points we have. E2 and then.
Use the 2 points that you. No, we need this. We don't want just the average slope. We want the exact slope at this point. How can I find the exact slope? Do I have some sort of slope formula that we can use?
The derivative.
What's our slope formula?
1 over X.
This one, right? dy dx, right? That's my y prime, that's my slope formula, right? It's given to us, so we can use it. So what's my slope going to be? 1 over e. That makes sense that your function can give you order pair, your derivative can give you the slope. Yeah.
So then we basically didn't need to find the order pair. Because it's just X.
Well, the derivative didn't need the y value.
Yeah.
But if we want to put it into point slope form, we do need the y value, right? Okay, so there's my tangent equation. I just replaced e and 2 in for x and y. I replaced m with 1 over e. And now part D, it says approximate y of 2.8. So there's an easy part here. How can I do that linear approximation?
Again.
Plug in 2.8 in for
X.
the x. Yeah, that's the x value. And then the rest is your calculator. Get that decimal approximation using your calculator. Yeah, we do have to move that 2 over to the right side and solve for y. That we're asking. Yeah, we need that too there. That's to move over to the right side.
We don't need the graph.
Yeah, the graph, yeah, we didn't need it. That was for the domain portion.
You want to do that work?
No. No domain on the test.
With no eventually.
Maybe I'll come back to it, AP review, but I'm not emphasizing that.
The only one which we found has to be the slope fields.
Mhm.
It's really. It's really.
Yes.
I did put the eight together, it's just either the one or you.
Yeah, you can do a second natural log, or you can do second division sign. See it? Yeah. Okay, how do you guys feel about that process? Do we want to do another one of these problems, or you feel okay with those steps? Because they will line up like this, where it's going to be a differential equation, of tangent line, and then linear approximation.
Yeah, like, where they give you like triggers all of them?
No trig with I mean, you may have trig with solving different equation, but the equation of tangent line, it won't have any trig in it. It'll just be something like that. So okay, let's move on to something else. But I think maybe you guys want to try number 1 on your own, because it has the same setup, solving different equation, tangent line equation, approximation. So maybe we can you can do that. A little bit later. Let me pick out some problems that that may be similar to the quiz. So, I mean, quiz topics will still be on the test. So let me create one problem and see how we deal with it. Okay. So this is on page 26. I have a blank page there. Can we tell by looking at this problem what category this is going to be? Synthetic, right? So we see there's only linear term here. There's more than one. If it was just one term here, I would go through expansion power rule, but more than one term here, we gotta go through synthetic division. Because the whole idea is that we want to kind of break this up into easier separate problems, and synthetic division can do that for us. Okay, so what can we put in as a coefficient for x cubed? 1. For x squared, it'll be 0. For x, it'll be -4. Stop there. Okay. Yeah, you can put a 0 here, but it may not get that far. Okay, bring the number down, multiply by -1. Add. Multiply. Sorry, yeah, we should have a 1 foot for the constant line as well. Okay, let's double check this. So 1 comes down, multiply by -1. Bring that number here, we add. Multiply again, -1 times -1 is 1. -4 plus 1 is -3. -3 times -1 is 3. 0 plus 3 is 3. Okay, let's assign the degrees. This is going to be 1 what? X squared minus 1x minus 3 plus this is, we call the what? Remainder. So we do 3 over what? X plus 1. Now we have taken one fraction and we split it up into 4 separate problems. Much easier to work with those 4 individual ones. The first 3 terms, we can just rely on what rule? Our rule. The last term is a little bit of use substitution. That'll turn into a natural log. Go from you can jump from here to here if you're comfortable, but otherwise you can also go through use substitution. Sorry, I don't know why I put that dx there. It should be plus c at the end. Let me change this a bit here. Okay, integral of 4e to the 5x minus e to the 4x all over 6e to the 3x. Can we split this up into individual fractions? Yeah, there's only one term here, right? So let's go ahead and do that. We couldn't do that before. But if there's only one term, we no need to think of this as one problem. We can think of this as a separate problems. Can we merge the e's together? Or bring this up to the top? What would that become then? Good, so subtract exponents, right? So this e to the 2x, this is going to be what? Just e to the x. So what if we do some cleanup here? The 4, 6 can be pulled out in front as what? 2/3. This can be pulled out as 6. Okay, let's do the easier one here. What's the integral of e to the x? This e to the x, right? There's no need for u substitution because that's just an x. So this one is quick and easy. But this one, we got to go through a little bit of what? Yeah, our u value is going to be 2x. Can you predict what's going to come out of that process? Yeah, which is 1/2, right? So you may be thinking times 2 because you think chain rule, but it's always going to be reciprocal. But we can always just be safe and just go through u substitution. to ensure that we know what's going to come out of it. I can pull that 2 out in front. The 2/3 just reduces to be just 1/3. So 1/3 integral of e to the u du, which is just basically 1/3 e to the u. Because we know e to the u is just e to the u. And then I can bring my x back into the problem. That's the result of this 2/3 here. And this one is just going to stay the exact same thing, right? Like e to the x won't change. So just minus 1/6 e to the x plus c. Okay, so study for your test. You know what topics that you need to be focusing on. Page 19, I think it's a really good review worksheet to do. I will do this tomorrow morning, and also I'll be available today during advisement. Okay, come get your phones. Yep. Yeah, 7:15. Yeah, if you want to take a picture of that, you can.